Alrighty, good morning, y'all. We are still working on this Unit 5 review. Activity 31 is solving quadratic equations, which is about where we left off. This was the last thing I know I covered when we, right before spring break, when y'all left. So, this is kind of the last little bit of review I have, but that's okay. We're going to cover this and we'll get on with it. So we get into solving quadratics here. If I could spell solving, that would be nice, but you know. Okay, so we're getting into solving. And if you recall, one of the first things you learned when you came into an algebra class was solving linear equations. Now we're getting into solving equations that have a squared in it, so we're solving quadratics. So there's a couple of different ways to do this. We have 5 different methods. Okay, and I'm going to kind of go in order from what I think is the easiest to what I think is the most difficult. And I don't even want to say most difficult, because it's really, none of them are really difficult, but they're used in different situations. So let's talk about our first method we have is solve by graphing. Solve by factoring, solve using a square root, solve by completing the square, and then solving using the quadratic formula. Okay, so before we get started in the actual math, I kind of want to just talk about each method. So I would use solving by graphing if it is an equation that's easy to graph, or if you actually already have the picture of the graph, or if you have Desmos. If you have Desmos, type your equation in, look for the intercepts. Boom, you're done. But if you don't have Desmos and you have to use algebra, or if you don't have Desmos, if you can graph it by hand easily, go for it. But I typically don't like graphing by hand, so this is actually my least used method. I only use it if I can just type it into Desmos real quick. Factoring is my go-to, but you can only use factoring if your equation can be factored. If your equation can't be factored, then you can't use factoring. That's kind of all there is to it. Like, I hate to say that, but I mean, if you can't factor it, then you can't factor it. So this is like the easiest easiest method, but it can't always be used. Okay, square roots are just as easy as factoring. But you can only use it if you don't have this term. If you have a linear x or an x without a square, like this one, you have an x squared and a regular x. If you didn't have this regular x, you could just take the square root of both sides and be done. But this does not, you have this term, so you can't take the square root. So again, square roots are easy if it's set up for you. Completing the square, you can always use completing the square, but sometimes it's not very user-friendly. I typically only use completing the square if my middle term is even. If it's not even, I'm not going to use it, because then I have to deal with fractions. And even though I prefer fractions to decimals, like every student I've ever had knows that I would rather use a fraction than a decimal any day of the week. I don't want to have to try to square it and do math with it. I just don't want to deal with it. And if I'm going to deal with fractions, I may as well use the quadratic formula because that's already got fractions in it. So quadratic formula can always be used, but it's lengthy. I don't really think this is hard, but it's such a big formula that I know a lot of students get intimidated by it. But it can always be used, and it's not super difficult. It's very lengthy, and when you have more steps, you have more places to mess up. So we're going to go over all 5 methods, well, let me see if we go over all 5. Actually, in this one, we only go over graphing and factoring. These are in activity 32. So we'll kind of ignore these for now, and we'll go straight into it. We'll just start solving by graphing and solving by factoring. I know I've spent a lot of time in this video and I haven't even started on the math, but I really think it's kind of important to kind of see where we're going with this. So when we solve equations, what we're looking for is the x-intercepts. We're looking for what x equals when y is 0. So if I have a parabola, I should have an intercept here and here. So when we solve these, since our solutions are our x-intercepts, when we solve these, we could have 2 solutions. So, and if we read right here, a quadratic equation can have 2 solutions, which is what we just drew here. It could have 1 solution, which would mean, if I had 1 solution, that would mean the vertex of my parabola is on the x-axis. Had to think about it. And then if I have no solutions, well, how can you have no solutions? Well, if I were to graph it, and it doesn't touch the x-axis at all. So you could have 2 solutions, 1 solution, or no real solutions. And this word real is important because in Algebra 2, you're going to learn about imaginary solutions. And here, if it doesn't have a real solution, it typically has 2 imaginary solutions, which sounds so super crazy. But it kind of makes sense, but not really. But that's more of an Algebra 2 skill. I'll mention it for fun. You know, Miss Gallant has a twisted sense of what fun is. But that's not something to worry about. But we do want to make sure that when we say we don't have no solutions, because we have solutions, they're just not real. So yeah, so math is so fun. Okay, so let's go on to number 1, solving by factoring. So I'm looking at this equation, and there's a couple of things I can do. I'm going to kind of cheat the system, though. I know most of you do not like using fractions. And when I factor, I don't want to use a fraction. I mean, even as fraction-loving as I am, whole numbers really are the way to go. So to cancel out this fraction, if I multiply 1/8 by 8, the 8's will cancel, and I'm just left with 1. But if I multiply one thing, I have to multiply everything in my equation. So let's do that. So if I multiply by 8, 8 and 8 cancel, and I'm left with negative 1x squared, or just negative x squared. 8 times 2x will be 16x, and 8 times 0 will still be 0. Okay. So now I'm looking, is there anything that I can... So since I've only got 2 terms, normally I have a trinomial like this, but since I have only 2 terms, let's factor out the greatest common factor from here. And the greatest common factor, the only thing I can divide both of these terms by is 1 and x. So I'm going to factor out an x, and that leaves me with negative 1x, or just negative x, plus 16. Remember, when you factor by greatest common factor, it's like dividing each term by something. And that number you divide by, you put to the side. It's basically doing the distributive property, or taking the distributive property and undoing it. Because if I were to distribute this x, I should get this negative 1x squared plus 16x back. Okay, so when we solve by factoring, it's important to make sure that we have these equal to 0. If these are equal to any other number, this doesn't work. So we want to make sure we have it set equal to 0. If I think about it, if you have two things that you're multiplying, something times something equals 0. Well, we know that to get 0 when you multiply, one of these two things has to be equal to 0. If it's not, you'll get a number. You'll get a number that's not 0. If I have 1 times 4, I'll get 4. If I have 12 times 42, I'll get not 0. If I want to get 0, I'd have to have any number I want here times 0. Or I could have this number be 0 and this number be something else. Or I could have 0 times 0 equals 0. So I am going to take that last statement. I'm going to set both of these equal to 0. Because if this term equals 0, when I multiply them, I'll get 0 out. If this term equals 0 and I multiply, I'll get 0. So that's what we'll do. So we'll take each factor and set it equal to 0. So I have x equals 0, and that's already solved for me because it's just x. And then I also have negative x plus 16 equals 0. And I could do this one of two ways. I know normally we try to get x by itself, we subtract the 16, and then we would divide by negative 1, but Miss Gallant is lazy. Something else you could do, you could cancel out the x, negative x plus x cancels, and you have 16 equals, and 0 plus x is x. It's the same thing. It's the exact same thing that you would have done if you had subtracted 16 and then changed your sign. I just moved it over here because it was less steps. You can do that. You're allowed to. Math is supposed to be lazy. I mean, it's a lot of work, don't get me wrong, but the whole point of math is to find easy solutions to everything. So my two solutions are x equals 0 and x equals 16. Now remember, these are the x-intercepts. So I can also write these as ordered pairs. And since they're x-intercepts, the y value will be 0. So my x-intercepts are 0, 0, and 16, 0. Okay, let's move on to B. I've already got a feeling this is going to be a lengthy video, and I apologize for that, but hopefully it'll be worth it. Okay, so B, we're going to factor this one. So this is a trinomial. It's set up beautifully for easy factoring. So let's look at this. When I factor, remember when we factor, we're looking for two binomials. This is x squared. There's nothing in front of x, which makes this easy for factoring. So we're going to just leave it as x and x, because x times x will give me the x squared. So I'm looking for two things that when I multiply them, I get 10, and when I add them, I get 7, or negative 7. So things that multiply to give me 10 would be 5 and 2. Okay? So this is positive, which means my signs should be the same. This is negative. So when I add positive 5 and positive 2, I would get positive 7. So in order for me to get negative 7, this needs to be negative 5 and negative 2. So I have x minus 5 times x minus 2. Okay. So x minus 5 times x minus 2. Alright, so now I need to solve for x. Remember, since we're factoring, we can set each of these equal to 0. So x minus 5 equals 0. X minus 2 equals 0. And this is why I like factoring, because once it's factored, you've got baby equations. Add 5 to each side, x equals 5. Add 2 to each side, x equals 2. Alright. Okay, C, we have x squared, minus 2x equals 15. So remember what I said earlier. You need to have your equation equal to 0. And this isn't equal to 0. It's equal to 15. So what could I do to this 15 to make this, what could I do to 15 to make it 0? Well, what I'm going to do is I'm going to subtract 15 from both sides. It will cancel here. And so on the left side, I'll have x squared minus 2x minus 15. And on the right side, I have 0. So that's an easy fix. Just move it over. And then you have a regular problem. Okay, so let's see. If I go to factor this, let me set up my binomials with x and x. Now remember, if you have a number in front of the x squared, you're not going to go straight to x and x. I would use box method, and I can do a quick video on that if we need to. But for right now, since it doesn't have an x or anything in front of x squared, you know it's going to be x and x. Okay, so I need numbers that multiply to give me 15, and subtract, since this is negative, subtract to give me 2. So the only thing I can think of is 5 times 3. So 5 times 3 will give me 15, and 5 minus 3 will give me 2. So if we look, this is negative, which means my two terms should be different signs. One of them should be positive, one of them should be negative. My b value is negative. So since b is negative, that means the larger of the two numbers is negative. So we have negative 5 and positive 3. Alright, so I have x minus 5 equals 0 and x plus 3 equals 0. I took both of these terms, set them equal to 0. I'm going to add 5 to each side. X is going to be equal to 5. And x is going to equal, if I subtract 3 from each side, negative 3. Okay? And don't forget, you can write these as ordered pairs. So this would be 5, 0 and negative 3, 0. And I forgot to do that with number 2. So number 2, here's my... We have 5, 0 and 2, 0. Okay. All right. Excuse me. Okay, so that is solving by factoring in a nutshell. Not too terrible. It's personally it's my favorite, because once you get it factored, you've got such easy equations to solve. All right, so number 2. Now this is probably easier than factoring. So I've got my equation. I've got the graph of it already. Use the graph to determine the roots. Well, remember, we already said that our solutions are the x-intercepts. So all I have to do is look where it crosses the x-axis. So my roots, or my solutions, or my x-intercepts, those are all the same thing, are, we have a point at 0, 0, and we have an intercept at 3, 0. No, I'm sorry, negative 3, 0. So we could say that x equals 0, and x equals negative 3. And then if you'd like to double check, we have the equation. And you could plug 0 in for y. And we could solve this by factoring if you want. Let's just do that just to get some practice in. So what I can do with this, since I don't have that third term, let's factor out the greatest common factor. I can divide both of these terms by 2, and they each have an x. And if I divide this by 2x, I'm left with just an x. Since it has an x squared and I took one of the x's, I'm left with 1x here. If I divide this by 2x, I'm left with just 3. The x's would cancel. Then set these equal to 0. Okay, so to get x by itself, I'd divide by 2. 0 divided by 2 is 0. So here I would get x equals 0, which is what I got here. Subtract 3 from each side, and you get x equals -3, which is what I got here. So that's just a good way to double check. You don't have to do that. And if it's a complicated quadratic that you're going to have to use the quadratic formula, I wouldn't check it. I'd just go off the graph. But if it's complicated and you're going to have to use the quadratic formula, 9 times out of 10 it's not going to be pretty on a graph, so you'll probably have to use that anyway. But that's just a good way to check. Okay, so number 3. We want to find the axis of symmetry and the vertex. Okay, so your axis of symmetry, remember when we graph, I'm going to do a quick little graph here. So if I graph it, and let me not do something super obvious. Let's do, let's do this. So let's say I have this as my graph. If I want the axis of symmetry, actually let's start with vertex. The vertex is that point from that's either at the tippy top, or if it's right side up, it's at the very bottom. Another good way to talk about it is this is the point where I go from increasing to decreasing. So I'm going up, I hit the vertex, and I start going down. So that's the point where we change from going up to going down, or from going down to going up. It changes direction at the vertex. So this point is the vertex. The axis of symmetry goes through the vertex. It's a straight up and down line that goes through the vertex. I abbreviate it as AOS because axis of symmetry is a pain in the butt to write over and over and over again. So this is the vertex, this is the axis of symmetry. And if you have a vertical line, we do x equals whatever that number to get that vertical line. So the axis of symmetry is the x coordinate of the vertex. So in order to get the vertex, you have to get the axis of symmetry first, and then plug that in to get the y coordinate of your vertex. Then we have determined the minimum or maximum. So your minimum or maximum is also the vertex. If your parabola is like this one, if it's upside down, it's a max. If your parabola looks like this, your vertex is your minimum. Okay, well, we're not graphing these, so how do I know if it's a maximum or minimum? Well, if your first term, if your x squared term is positive, if you have a positive a, it's going to look like this and have a minimum. If your a is negative, your parabola will reflect over the x-axis and look like this, and you'll have a maximum. Okay, and then the last thing I want to talk about is, well, what's this a and b thing? Remember, in standard form, I'm going to do this in a different color. When we have standard form of a quadratic, we usually have y equals, or f of x equals, ax squared plus bx plus c. So the term in front of x squared, or whatever the coefficient is a. The coefficient in front of x without the square is b. And the coefficient, well, it's not coefficient, the constant without an x, the constant is c. Alright, so our axis of symmetry, we have a formula. If you were in my class, we did a little investigation, and we discovered that, hey, every time we do the vertex and we look at a and b, it does this, it you can do this with A and B and get the axis of symmetry. We did a little investigation activity, and that's how we got the formula. But if you are a trusting person and you trust me, you can trust me that this is the correct formula. It's actually part of the quadratic formula as well. It's kind of neat. The person who first discovered it was a lot smarter than I am. So, okay, so we're going to use this formula to get the axis of symmetry. Okay, so we have negative b over 2a is our formula. So x equals negative b. Well, if I look at my equation, my b value should be in front of the x. So b is 2 over 2a. All right, and my a value, so there's nothing in front of x squared. So we're going to say that our a value is 1 because we have 1x squared. Even though I didn't write a 1 in front of it, we know that we have 1. We see it. All right, so let's start simplifying this. We have negative 2 on top over 2 times 1 is 2. And if I divide that, negative 2 divided by 2 is negative 1. So x equals negative 1. That is my axis of symmetry. Okay? Now to get my vertex, man, I don't have any room. Let's see if I can do this on a separate sheet of paper. Yeah, this will work. Okay, so to get my vertex, we're going to take this, y equals x squared plus 2x minus 8. And everywhere I see x, I'm going to plug this negative 1 in. So this is going to be y equals, and remember, when you plug these in, always use parentheses, especially if you're using a graphing calculator, because the order of operations for squaring a negative screws up in the calc. Well, it doesn't screw up. I understand where it's coming from, but you're not going to get the answer you want if you don't use parentheses. I don't want to say the calculator is wrong, but it's an input thing. You have to have the parentheses for it to work in the calculator. Okay, so negative 1 squared. Well, negative 1 times negative 1 is positive 1. 2 times negative 1 is negative 2. And then I'm just going to bring down that negative 8. So 1 minus 2 is negative 1. Minus 8 should be negative 9. So negative 9 is not my vertex. My vertex is the x and y coordinate together. So we'll put vertex, and we're going to do negative 1. That was our x value. And then we got negative 9, so negative 9. Okay, so let's look at this. A is positive, which means it's going to be an upright parabola, which means it has a minimum. So my minimum, remember, is only the y value. It's the lowest point. Well, that vertex is the lowest point. So my minimum should be negative 9. The vertex is always going to be your min or max. Always, always, always. All right, so I'm going to do all my math on the second sheet of paper and then just put my answers on this sheet of paper because I wrote a lot of info, and I think it's worthwhile. I think you need it. But, so yeah. Okay. Second problem. Y equals negative x squared plus 4x minus 5. Okay, so for the axis of symmetry, we need to use our negative b over 2a formula. Okay, so we've got negative, my b is 4, over 2 times a. Well, my a here is negative 1. You see how there's a negative in front of the x squared? So we're going to keep that in our formula too. So our a is negative 1. All right, so when we simplify, we have -4 up top. 2 times -1 is -2. 4 divided by 2 is 2. Negative and negative cancel. So my axis of symmetry is x equals 2. So we'll write that here. Okay. So for my vertex, and just a quick note, because I'm going to hear this question a lot. Or if I were teaching this in class, I'd hear this question a lot. And that question would be, Miss Gallant, is A always going to be 1 or -1? And that's not true. It will not always be 1 or -1. I think right now, just to keep it easy, all of the problems have 1 or -1. I don't see any in this. I see a few that have A values that are not 1 or -1. We'll get to those later, but just know that it's not always going to be 1 or -1. Sometimes you'll have different numbers in front. Okay, so x equals 2. Okay, so now we want to get the vertex. So we're going to take 2 and plug it in for x. So this is going to be, and we use blue, y equals negative, because this is negative, x is 2 squared. So you might be wondering, well, why didn't you put the negative in parentheses with the 2? Well, here, the negative, x is not negative. If x were negative, I would put it in, but x isn't negative. X is a positive. So I put that in parentheses, and the negative here would go on the outside because it's saying take x, square it, make it negative. Okay. Here, this was saying square x. So x was -2, so I had to square the -2. Okay. So we have y equals -2 squared plus 4 times x, and x is 2 minus 5. Alright, so 2 squared is 4, and then if I make it negative, that's -4. 4 times 2 is 8, and then minus 5. Okay, so -4 plus 8 is 4. 4 minus 5 is -1. So my vertex, remember my x is 2 and my y is -1. So my vertex is 2, -1. All right. And then my minimum or my maximum, well, let's see which one it is. This is negative out in front. So that means this is going to be a maximum. So that would be here. So my maximum, yeah, the negative's the maximum. So my maximum is going to be -1. That's the highest x value I have is -1. All right. Okay. All right, so then we have y equals -x squared plus 8x minus 20. All right, so we're going to use our axis of symmetry formula. -b over 2a. And let's see. So we have negative, b is 8. Over 2 times, and then a is -1. Alright, so when we simplify this, we have -8 over -2, which comes out to +4. So my axis of symmetry is x equals 4. It's important that we keep that x equals for our axis of symmetry because remember, it's a line. And it's a vertical line. So we do need to make sure it has x equals for our axis of symmetry. Alright, so for our vertex, we're going to plug 4 in for x. So y equals negative 4 squared plus 8 times 4 minus 20. Okay, 4 squared is 16, and then we'll make it negative. 8 times 4 is 32 minus 20. Okay, so negative 16 plus 32 was the same thing as 32 minus 16, which is 16. So we should get 16, positive 16 minus 20, which will give us negative 4. So our x is 4 and our y is negative 4. So our vertex is 4, negative 4. Then this is negative. So that means we have a max, not a minimum. And our max is negative 4 here. Okay, so this video is already 36 minutes long. And I know we're not anywhere near through with activity 31. So let's see, how much longer, how many more pages is this? Oh, wait a minute. Okay, never mind. I was going to say, I think we have a whole nother page, but we actually only have 2 more problems. So I was going to stop it and make a second video, but I think we can just push through and get these last two problems done. I didn't realize I was looking ahead and thinking that we had more guided practice, but we don't. This is it for guided practice. I'm having a day. Okay. Alright, so number 4, graph the quadratic functions by finding the vertex and the zeros. Okay, so in order to graph these, we have to do everything we just did. We have to find the axis of symmetry, the vertex, and the zeros, or the x-intercepts. And then we should be able to graph it. So, let's look at that. So let's do the axis of symmetry first. Okay, and then we'll do vertex. And then we'll do intercepts. Okay. So my axis of symmetry, remember, is negative b over 2a. So negative, let's look at what b is. B is negative 2 here. So we have negative, negative 2 over 2 times, well, what's my a value? It is 1. So we have negative, negative 2. So that's positive 2. 2 times 1 is 2. So my axis of symmetry, if I divide 2 by 2, is 1. So my axis of symmetry is x equals 1. So what I'm going to do, so remember the axis of symmetry is an imaginary line. Ooh, this is hard to see. We're going to say that this is 1. I draw a dashed line here. It's not super important, and you don't have to draw that dashed line. But for me, it's easy. That makes it easy to see where the vertex is supposed to go and how far apart everything should be from itself. Okay. All right, then the vertex, we're going to take 1 and plug it in for x. So this becomes 1 squared minus 2 times 1 minus 3. Okay, 1 squared is 1. 2 times 1 is 2. And then we have minus 3. 1 minus 2 is negative 1. Yes. And negative 1 minus 3 is negative 4. So my vertex should be 1, negative 4. Okay. So 1, negative 4. So I'm going to go to 1. I'm going to go down 1, 2, 3, 4. and put a point. That's my vertex. Now real quick, we see that this is a positive x squared. It's a positive a. So here, what I know I can do is this is going to be going up. So it should go up. All right, so for my intercepts, we're going to change this y to 0 first off. So this is going to be x squared minus 2x minus 3 equals 0. Okay, so we have that equal to 0. Just thinking through. My head's kind of, it's been a minute. This is 40 minutes in. I'm kind of getting tired. Okay, so have this equal to 0, because remember, we want the x-intercepts. Our x-intercepts always have a 0 for y. Alright, so let's factor this. I am looking for numbers that multiply to give me 3, but subtract to give me 2. The only thing that multiplies to give me 3 is 3 and 1. Okay, now this is negative, which means these are going to have different signs. And my negative 2, or my 2 is negative. So that means my larger number is negative and my smaller number is positive. So negative 3 plus 1 does give me negative 2. Negative 3 times 1 gives me negative 3. Set them equal to 0. And we get, when we add 3 to each side, we get x equals 3 and x equals negative 1. So my intercepts are 3, 0, and negative 1, 0. So I have 1, 2, 3, 0, 0, negative 1, 0. Okay. And you could find more points if you want. I'm just gonna get a basic shape. I'm gonna make sure it looks more rounded and not V-shaped, because we don't want people to think that this is an absolute value function. We want to make sure people know it's a quadratic. So just make sure you don't make that a point and don't make them straight. Make sure it's curved. Alright, last problem, and then you'll be done hearing me for the day, unless you're just doing like a marathon of all my videos, which if that's the case, I'm sorry. Okay, so let's find the axis of symmetry, the vertex, give us a little more room this time, and the intercepts. Okay, axis of symmetry, negative b, well here b is negative 6, over 2 times a, well here a is negative 1. Negative negative 6 is positive 6. 2 times negative 1 is negative 2. And 6 divided by negative 2 is negative 3. I wrote that backward. Like, that bothers me. So my axis of symmetry is x equals negative 3. And so I'm going to go over to negative 3. 3. I'm just going to do a dashed line. Again, when you graph, like if you were to graph this on Desmos, you would not see the axis of symmetry. That's why I'm trying to do like a teeny tiny dashed line. It's just a guide to help us graph it. It's an important guide, but it is a guide. All right, my vertex, I'm going to plug negative 3 in for x. So this is negative 3 squared minus 6 times negative 3 minus 10. Whew, that's a lot. So negative 3 squared is positive 9. Negative 3 times negative 3 is positive 9. Then we have this negative here, which is going to go in front. So we have negative 9. And then we have negative 6 times negative 3 is going to give me positive 18. And then we have minus 10. Okay, so negative 9 plus 18 is going to leave us with positive 9. Positive 9 minus 10 is going to leave us with negative 1. So my vertex is negative 3. That's what we had for x. Negative 1. So I'm going to go down just to negative 1. There's my vertex. Okay. So I want you to notice something here. This is a negative graph, right? And my vertex is negative. So we should not have any x-intercepts. So let's look at that real quick. Let's just double check. So we have 0 equals negative x squared minus 6x minus 10. Okay, let's divide, or let's factor out the negative 1 and divide. Like, we can cancel out all the negatives. We can say 0 equals x squared plus 6x plus 10. Basically, I divide everything by negative 1. So I need numbers that multiply to give me 10. The only numbers that multiply to give me 10 are 1 and 10 and 2 and 5. They also have to add to give me 6. Well, 1 plus 10 equals 11 and 2 plus 5 equals 7. So there are no real solutions here. There are no real solutions here. All right, so that's kind of a pain. So if we want to graph this, we're going to have to find some x values and plug them in. Let me see. I'm running out of room. That's why I'm like, ugh. I'm trying to think if my pattern would work, though. I think it would. There's no a value. Okay. I don't want to confuse anybody. Okay. So what we're going to do, we're going to pick one more number. So we're going to pick one more number. That's going to get, one number is going to give us 2 points because we have an axis of symmetry. I'm going to plug 0 in for x. And the reason I'm picking 0 is because it's an easy number to work with. Okay? 0 squared is 0. Or, well, 0. Minus 6 times 0 is 0. 0 minus 0 is 0. We don't even need to worry about zeros. We're just left with negative 10. So we have a coordinate at 0, negative 10. Okay? So I plugged in a random x value. If you get to where you have no real solutions but you still need to graph it, plug in 0 if you can't. Plug 0 in. Okay, so I plugged 0 in and got negative 10, which would be down here. So we're going to use our axis of symmetry. Okay, so if I look, this point at negative 10 is 1, 2, 3 units away from the axis of symmetry, which means I should have a point at negative 10, 1, 2, 3 units on the other side. And now I got some points. I can round this out, make it a quadratic. It's not a very pretty one, but boom, it's graphed. Okay, so this one has no real solutions. That's really important. It does have 2 imaginary solutions, but we're not going to get into that this time around. We'll probably get into that next lesson. So thank you so much for paying attention. I know this video is almost an hour long. I know that's super, super long, but this is a really important lesson, and this is where we left off, and I really want to make sure you understand it. So please feel free to email me, or if you're not my student, email one of your teachers if you have any questions. If you're not my student and want to clarify something that I particularly explained, feel free to email me. It's, you know, the same as your teacher's email. It's just with my name. I don't want to give it out all over YouTube, so, you know, but, you know, so shoot me a question or put a question in the comments. Anyway, I hope this was helpful. I know it was super long and super detailed, but I hope it was helpful. If you have any questions, let us know. Hope you guys are staying safe, staying healthy, and I'll have another video for you guys soon. Thank you so much. Bye.